try to record this again, this time with some sound, hopefully. Starting with this slide, you probably want to pause the podcast, get these notes written down, because this is the obviously critical information that you need to know. A lot of the vocabulary that goes along with this section. You also should probably know the theorems that are associated with this section. So ignore that bell. You do not have to get up and leave or go do anything right there. So make sure you're looking over the theorems as well. A lot of that can be found in your online book. So make sure you're checking the book, reading the book, knowing what's going on as you prepare, probably for a retake of this quiz, because a lot of people are going to be watching this in preparation for that. All right, just going through the review problems again. We talked about this situation here. Obviously, since BD is perpendicular to AC and B is equidistant from points A and C, meaning that these two segments are congruent, we know, therefore, that BD is the perpendicular bisector of AC. Because we've got the perpendicular part, we've got the equidistant from the endpoint, so that makes the perpendicular bisector, which means these two segments must be congruent. So then we do our algebra. E equals 8x minus 3. And I get 3x equals 15. Divide by 3, and x is 5. However, the question asks us to find BC. That's what the question asks us to do. So we have to substitute this back in. I'm sorry, not BC, DC. BC we wouldn't be able to find. Here we go. How about D in blue? There we go. So DC is 8 times 5 minus 3. We have to substitute that 5 in for x. So that's 40 minus 3. So 37 is the length of DC. Here the problem asks us to find, and again this is important, asks us to find KJL, that whole angle. Now again we have to identify what's going on in this picture. Obviously the point F here is equally distant from K and L, from JK and JL, because it's a right angle distance. So that means F is on the angle bisector, which means that these two angles must be congruent. So again, 4x minus 1 equals 3x plus 8. Subtracting the 3x, adding the 1 to both sides, I get x equals 9. Now again, that's not my solution, that's the value of x. I have to substitute that back in, but this time I have to substitute back into both equations because I need both measurements so I can add them up to get the angle I'm looking for. So 4 times 9 minus 1 is 36 minus 1, which is 35. And 3 times 9 plus 8 is 27 plus 8, which also equals 35. So my angle, KJL, is 35 plus 35, or 70 degrees. So again, make sure you answer the question that's being asked. I've said that a lot this year. This question asks, do I know that A is D on the perpendicular bisector, or is AD the perpendicular bisector, and is AD the angle bisector? Well, here I can tell, yes, it must be the perpendicular bisector. It clearly bisects, because D must be the midpoint, obviously, from the fact that those two segments are congruent. I know it's the perpendicular bisector because A, this point A here, is also equidistant from B and C. And again, those are the properties of a perpendicular bisector. Any point on the perpendicular bisector, okay, is equidistant from the endpoints of the segment. Okay, that's one of our theorems. That's how I can tell it's on the perpendicular bisector. So part A was yes in the review. Part B asked, is it on the angle bisector? Well, this is a little more difficult, but again, once I know this is a right angle, then the triangles are congruent because of hypotenuse leg. And if those triangles are congruent, that means their corresponding parts must also be congruent. So AD is also the angle bisector. It's a little more roundabout way of getting to it, but I can prove it. Here, AD is clearly not the perpendicular bisector of BC because BC isn't even a regular segment. Okay? There is no segment BC there. I mean, I could draw one in, I suppose, but I have no way of determining if that's the perpendicular bisector. Because I don't know any, the only distances I know are CD and DB. Now, I do know those two segments are congruent, but I don't know that this is a midpoint here or that it's a right angle, this point right here. So there's absolutely no way to determine if that's a perpendicular bisector. Also, it's not on the angle bisector, so both are no in this case, because I need to know that these are right angles, okay? I don't know if these are right angles or not. If I knew that, then it would be the perpendicular, or the angle bisector. AD would be the angle bisector, but it's not. So for these problems, the answer was no. All right, finding in this case the circumcenter. We're asked to find the circumcenter of this. By the way, I'll make that a P. So we start by plotting our points. Our points are at 1, 1, 5, 1, and 1, negative 7. Okay, so I have M, N, and P. Now, we're going to draw those carefully, or as carefully as we can on a smartboard. Came out pretty good. And now, in order to find the circumcenter, we have to find the perpendicular bisectors of each side, which means we have to find the midpoint of each side. Bisector means midpoint. Now, because the right triangle, it's a little bit easier. Finding the midpoints is fairly simple with horizontal and vertical segments. This segment is 4, MN here is 1, 2, 3, 4 units long. So obviously right smack in the middle is there. This one is 1, 2, 3, 4, 5, 6, 7, 8 units long. So right in the middle is there. And then I can just construct those perpendicular bisectors. That's fairly straightforward. And we find that our circumcenter is right there at the point 3, negative 4. So circumcenter is found by finding the perpendicular bisectors of each side. And again, with a right triangle, that's pretty easy. If it's not a right triangle, then we also have to find the slopes of the sides and find the slope of a perpendicular line. But usually we make these fairly simple. This one asks for the centroid. Okay, the centroid is where the medians intersect, and medians connect midpoints to vertices of the opposite side. So my points are at negative 1, 2, A, B is at 2, 7. That's a little higher than that, okay, and C is at 5, 0. So again, I'm going to draw my triangle carefully, or as carefully as I can on the smartboard. You should be using a straight edge for this if you're doing it. And now I need to find the midpoint of each side, so I can connect that. So now I have to do some midpoint formulas. Midpoint AB would be at negative 1 plus 2 over 2, comma, 2 plus 7 over 2, using the midpoint formula. If you do not know the midpoint formula, you need to look it up and review it and learn it. That's something we've done so many times this year. This gives me 1/2 and 9/2. So the point 1/2 9/2 is 1/2 over 1/2 up 4.5. So over 1/2 up 4.5. 1, 2, 3, 4.5, right about there. Okay, there's my midpoint. I now construct my median. Boom. Next, I find the midpoint of AC. So that's -1 plus 5 over 2, 2 plus 0 over 2. So that's 4 over 2, 2 over 2, or 2, 1 is that point right there. Again, I'm going to connect my dots, vertex to the point on the opposite side, and boom, where those two intersect. And I could construct the third one if I wanted to, but where they intersect, if we've drawn carefully, is the point 2, 3, which is the location of my centroid. Now, one other way of finding a centroid, which someone just explained to me today, I did not know this, none of us did in the math department, we just found this out today, but one way that should also work is if I add up all the x coordinates, -1 plus 2 plus 5, and divide by 2, and add up all the y coordinates, 2 plus 7 plus 0, that's not going to work in this case. Never mind. Someone suggested that works, but I don't think it does in this particular case. Let me try that again. -1, maybe it was divided by 3. Plus 2 plus 5 over 3. 2 plus, plus 0 over 3. Sorry, it's divided by 3. When I do that, this gives me 6 over 3, 9 over 3, which is 2, 3, which is the coordinates of my centroid. Yeah, that does work. Sorry, it's not divided by 2, it's divided by 3. Actually, I just learned that today, and I'm recording this on Wednesday afternoon. So, yeah, kind of useful. This one is straightforward. We simply set them equal, substitute in. 3x minus 5 equals 2x plus 4. It's an in-center because it's equidistant from the sides. Okay. So x equals 9, substituting that back in, 3 times 9 minus 5 is 22, and all of these have to be 22 units long, equidistant from the sides. We then got into the whole find the equation of a line or the perpendicular bisector between -5, -2, and 1, 4. Now remember, from a graphic standpoint, what we're doing is we are finding the perpendicular bisector of a segment that has endpoints at -5, -2, and 1, 4. So here's my segment. I need the perpendicular bisector of that segment. In order to find a perpendicular bisector, I need two things. I need the midpoint of that segment, which would be -5 plus 1 over 2, -2 plus 4 over 2. Or that's -4 over 2 and 2 over 2, or -2, 1, which, by the way, makes perfect sense because there it is, right in the midpoint. Now I need to be perpendicular to this line. I need a line that is exactly perpendicular. Okay? I need to find where that line is. I'm not sure where that line is. In order to find perpendicularity, I need to measure slope. So I need to find the slope of my segment, which is change in y, -2 minus 4, over change in x, -5 minus 1, which is -6 over -6. In this case, that reduces to 1. So the slope of this line is 1. The perpendicular slope is a negative reciprocal, which would be -1 over 1, which is -1. Once I have a point and a slope perpendicular of that line, I know what the slope has to be now, -1. I can find the equation of that line using y minus y1 equals mx minus x1. So y minus 1, I'm sorry, y minus, thinking of the wrong point. It's -2, 1, so y minus 1 is correct, equals -1 x plus 2. And I have to distribute the -1 and add 1 to each side. If you're fuzzy on this whole process of finding the equation of a line, you need to go back and review some stuff from Chapter 3. That's where we did it, or from algebra. Because what we're doing is we're finding the equation of essentially, oops, you have to move that. Essentially, we're finding the equation of that line right there. That's what we're finding. And that's the exact equation. So you need 3 formulas here. You need a midpoint, slope, and equation of a line to solve that problem. 9 through 11 is straight up vocab. It just goes right back to that first slide that we had. And knowing what these things are, the perpendicular bisectors, angle bisectors, medians, and altitudes. That's critical. So obviously, this is the type of stuff that's going to be very, very, very important on the quiz. Make sure that you are understanding and knowing these facts by heart. If someone says median, you know that that goes with a centroid. And you know that the median goes from the vertex to the midpoint on the opposite side. This vocabulary, these descriptions, absolutely 90% of what we're talking about in this unit. A lot of people lost a lot of points because when asked to find the centroid, they found the orthocenter instead. Or when asked to find the perpendicular bisectors, they instead did altitudes. So keep this stuff in mind, work hard on this stuff over break, come back ready for a good retake.